C. elegans nicotine addiction with respect to exposure at different stages in life and with different dosages. So first, I want to talk about why C. elegans are important. And this is an image of a C. elegans. And they're multicellular, but they're simple, so they are similar to like humans, but they have a very simple system. I don't know why the thing is wrong, I'm sorry. It has a nervous system, which is important for my study of nicotine because nicotine involves the nervous system. We'll talk about that in a little bit. I'm really sorry.
Check your...
Yeah, I can check that. Everything is right on it, so I don't know why this is happening. But do you want me to check it?
Okay. If you needed to reference, it might be different on that screen. I'm not sure.
Okay. Oh, probably. So, additionally, its effects to nicotine are similar to those of humans, which is important in studying, because if you study the worms and you find something out about them, it can be brought back to humans and then can be studied further on humans because the genomes of the C. elegans and the genomes of humans are very similar. And another very important thing about the C. elegans is their whole genome is already coded, so any sequence that you would need is already found out about. So then, what's so bad about nicotine? So I chose to study nicotine because there's been previous studies about it in the C. elegans, but its negative effects because I'm not studying smoking, obviously there's nothing going to be wrong with the lungs of the C. elegans, but there's like issues that happen within the brain. So this is an example of what the nervous system would look like, and there's acetylcholines, which are little receptors in the nervous system, and those are what's responsible for the binding of the nicotine. Those have to be present for the nicotine, for the addiction to happen. And so when the acetylcholine receptors bind to the nicotine and they go up the axon terminal, which is part of the nervous system, all of these effects happen. And so there's an uncontrolled release of the acetyl receptors, and the acetyl receptors are involved in things such as the cerebral glucose and the endorphins. And when nicotine binds to them, they are released in a large amount, and they can't be controlled by the body because they're seen as foreign. So as a result, all these endorphins and all of these effects happen, and so you feel really happy, and there's these positive effects, but it's harming the brain. For example, in several studies, they believe that their cerebral glucose levels are increased, and an increase in cerebral glucose levels happens in people who have like ADD and ADHD, and so by consuming large amounts of nicotine, you could in turn be giving yourself ADD. And so those are not positive things of nicotine, and so as a result, I think that studying nicotine would be something that would be beneficial. So previously studied, there was at Stanford, they invented this worm tracker, and so what it is it's a camera, and when you have the worms, and you put the camera on top of the worms and you study it for about 5 hour increments, and it's a whole software that actually then studies the speeds of the locomotion of the worms. And so it's a little complex right now. I'm like looking into it further, but it's a program called MATLAB, which is a computer software program, and then pretty much it has different levels, and it'll tell you the speeds and the different locomotions. So I'm going to use that to compare the different speeds of my worms. And so additionally, one other Professor Fang, he's done a lot with nicotine. He has several different articles, and he has determined that by studying the withdrawal and different parts of nicotine addiction, which would be the actual addiction, the withdrawal of it, and then the tolerance to it, he studied that correlation between humans and C. elegans, that they're similar, and so the study can work because it has been previously determined that they're similar in the way they react to the nicotine. And then as well, Park used the worm tracker in his experiment to study the exposure of nicotine, and as a result discovered that a rapid increase in the locomotion of the worms will occur when nicotine is exposed to them. So those are all helpful to further your experiment. No one has ever done the experiment that I am choosing to do. It's simpler in that there's involved in the nervous system is a very complex system, and so there's different channels, and there's an NACHRP receptor, which is the equivalent to the acetoreceptor in the human. And so they have all studied different things, but I want to focus my study on how, with nicotine, there's been ways to, wean off of nicotine, and in the past people have used nicotine patches, and there's nothing that's proven the success of them besides people's stories. And so I wanted to see that by giving different dosages of the nicotine to the worms, how they would react, because in that case that could be applied essentially back to humans, and to see if that proves a plausible way to wean off of the addiction of nicotine. And so what I chose to do is I have several different treatments based on how old they are and how long they're exposed to the nicotine. So I have 4 treatments, 2 treatments for the question of how will nicotines react to the different dosages of the nicotine, how will the C. elegans react to the different dosages of the nicotine. And so for that I chose to do one treatment where there's a petri dish of about 20 C. elegans. I have to see when the culture kit comes how many are in each kit, but 20 C. elegans in one petri dish, and they'll be exposed to 1.5 micrometers of nicotine, and then that'll be placed on the bottom of the E. coli dish with their food, and then that way it's absorbed through their whole body. And then the other half will be exposed 1.5 micrometers for a shorter period of time to see how long-term and short-term effects would affect their locomotion. And then the other half would be exposed to the smaller dose. The dosages are equivalent to how one would be almost like a cigarette and the other one would be like a nicotine patch. And so the different, if you were smoking a cigarette and then trying to wean off of the addiction, how you'd be affected. And so that's sort of where the variables come in, the numbers. And so then the second one would be the 500 nanometers for different periods of time. And then the other treatment would be during their stages in life. So, stages in life? Yes. So then 1.5 would be given to a young C. elegans and 1.5 would be given to an older one, because additionally in Park's experiment he discovered that younger people are more susceptible to an addiction than older, which makes sense because your brain hasn't fully developed yet. And so I wanted to see how that would affect this experiment, and if you were addicted earlier and if a nicotine patch, how you would react to that in a sense. So then you would have 1.5 microliters to young C. elegans and then to the older. And so in that case I would have to be breeding the C. elegans. I need to see how that's going to work when I get the Carolina kit and the instructions on how to culture them. But then I'd be giving it to the younger and the older and different dosages and comparing that. So my hypothesis is that I don't think that the reactions between the 1.5 microliters and the 500 nanometers is going to be very different. I don't think it's a very big amount, and looking at other studies, the differences in the nicotine didn't prove very different to the way the worms moved and their locomotion. They remained at a steady pace. And so I think that in that case, I do think that along with the other experiments, the younger C. elegans are going to be more susceptible to the addiction, and they're going to prove either the locomotion, depending on what the worm tracker says, it's going to be very different than what the older is going to be. I think either they'll move faster, but I think you'll be able to determine very clearly that they are more susceptible to the addiction. And then I also think that the higher dosage with the lower dosage won't be a very big difference between them. And so the significance of this is that people have been using nicotine patches as a way to try to get off of an addiction, but if this experiment proves that the C. elegans do not change the way they move and the way they react to the different dosages, then perhaps it's not a very effective way or a way at all to try to get rid of an addiction if it's already damaged the brain. And although you would have to study this further in humans, studying on C. elegans, if they don't show any difference, then I think that's like a really big thing, because there have been products that have been made that don't.
Okay, so I'm confused about how you make the connection between locomotion and addiction. Because, I mean, it's possible to, like, be exposed to nicotine and not be addicted, right?
Yeah.
it's possible to not be. So, because when they're like under the influence of the nicotine and they're like extra wiggly, how do you know that they're now reliant on that nicotine to be wiggly? Like, how do you know that they've actually been addicted?
Okay, well, from reading the previous articles, the way that you can tell they've studied how, by studying them, and I'm going to probably do the experiment each week to see how that changes. So if the first week, the locomotion, the worm tracker determines like the speeds, and so comparing, there's going to be a control for each one, so comparing the speeds of the one that doesn't have any nicotine just on an equal plate compared to the ones that do have nicotine, the way they move, and then in comparison to various weeks, can determine if they become tolerant to it, because I'm not changing the dosage. So the first week will probably tell me the most about how they react to it, because in previous studies they've studied the symptoms, the withdrawal, and tolerance to it, and so the various steps of how they've reacted. And so by farther weeks, they're probably not gonna even change, showing that they've become addicted to it. If that makes sense. Because to become once you're addicted to something, you would have to increase the dose to feel the same effects. So by not increasing the dosage, and their effects should, by the end, stay the same as what the control is, showing that.
Yeah, okay,
Does that
yeah.
make sense?
Yeah, it
Okay.
does.
So you're using tolerance to indicate addiction?
Right.
Would you consider doing, in addition to your control that doesn't have any and your tests that are giving different dosages, also putting a worm on nicotine and then seeing how their locomotion changes if you take them off of it? So start them for a month on it and then see what happens to them when you stop giving it to them?
No, I didn't. I was only thinking of doing it after each test, putting them off. But
Do you think that
I
that
think
would
that
reveal
would.
anything? Or is it just tolerance will sort of show the same thing?
I think that could reveal something, if it went on and then went off and determined if it went back to the normal way, because that could show that it, managed to get the symptoms of nicotine out of its body without.
Yeah, or if it was extra slow and didn't feel like moving at all.
Right.
Maybe it would be depressed.
Because it didn't have nicotine, yeah. And there's a bunch of studies that show further in depth the way that they responded in each sort of step. And so I can look at those and can kind of compare that to the reactions of the worms. And then along the worm tracker has things built into it. It pretty much shows, it's sort of confusing right now, it only works on a PC, so I have to download it on that. But it shows the worms almost with little X's, so it's heat almost, and it shows the way they move. And then I can compare those numbers with numbers of previous experiments to see how they reacted.
Are these C. elegans reproducing in the culture?
I believe they will be.
And do you think that there will be any natural selection occurring?
Well, what I wanted to do, yes, I do think there would be natural selection occurring depending on how they react, if probably selecting towards having the nicotine. But I wanted to test at the end. I haven't figured out the strain yet, which is why I didn't present it, but they're the wild type strain of elegans, and they have these different subsets of the receptor, and so it's sort of confusing that I have to look further into, but it's the UNCs, and they have these different, they're called TRP channels, and that's what is responsible for nicotine. So then at the end I could test to see if some of them don't have them present, which in that case they would have evolved to not become addicted to the nicotine, because you have to have that to become addicted. So I could test it at the end, and I think that would be really interesting to see. If that makes sense.
I have a question about the form of the nicotine that you were going to be testing.
Yeah.
So you were explaining it in micrometers, nanometers. So does that mean is it not a liquid form?
No, it's like a powder that has to be reduced down to a paste, and then is put on the E. coli.
So
Agar.
how can you be sure that the thickness of 1 micrometer? I guess my question is, how do you know that it's the same amount if you're just measuring length rather than having a weight
What do
or
you mean by
a
length?
volume?
How do we, micrometers and nanometers, I suppose what I'm saying, are length.
Length.
So
Right, and then there's all, yeah, okay, yeah.
So do you maybe mean liters or?
It's like grams, but then the micromoles as well, what it was testing. But it tested micrometers.
So they were
in their
using it
studies.
to describe like the distance of in the plate maybe?
Yeah, I need
So
to.
that's something to think about
Yeah.
the dosage and how to